express each of the following integrals as a gamma function and then evaluate numerically both the gamma function and the original integral if by computer if needed. Okay, so I'm gonna go ahead and do problem number 12 to show you how to arrange this one. So I'm gonna do this question here, and what we know from this section, this is, by the way, section 11.3. We know that the gamma function of p is equal to the integral from 0 to infinity x raised to the p minus 1 e to the minus x dx for any p greater than 0. Okay, so the trick is to turn number 12, the form of the integral in equation in problem 12, into the form that I just wrote, e to the minus x. Notice that in my question I don't have e to the minus x, I have minus x cubed. So what I will do, I will use a substitution. I will say let k equal x cubed. So I could have the form that's written in this definition, in the gamma function definition. Okay, so that means if I were to differentiate here, because I need dx as well, dk will equal 3x squared dx, and then I could put it back. So by if k equal x cubed, then I know x equal cube root k. Okay, and I will plug in back into equation back into problem 12. Now notice that the bounds don't change, because if x is 0, so is k, and if x is infinity, k is also infinity. So the integral remains 0 to infinity x now is cube root k, or let's rewrite it as a power. So k to the 1/3, that's x, and then this would be e to the minus k. And then dx is just dk divided from this here, divided by 3x squared, and I have to get rid of x, so x is cube root k, so k to the 1/3 squared becomes k to the 2/3, right? Because originally I have, right, because I could say here x squared is equal to k to the 1/3 squared becomes k to the 2/3. So I replaced x squared with k to the 2/3, and then I could simplify this, of course, bring the 1/3 out, and then I have 1/3 k to the 1/3 over k to the 2/3. That would give me k to the minus 1/3 e to the minus k dk. Okay, and now you could see that I am close. I'm trying to make this form so k to the minus 1/3, I could rewrite this as k to the 1 minus 2 or 1 second, this has to be p minus 1, so this would be 1/3 minus 1, right? K to the 1/3 minus 1, because 1/3 minus, or 2/3 minus 1, I apologize, because that gives me minus 1/3, because 2/3 minus 1 is 2/3 minus 3/3 will be minus 1/3, and here I have e to the minus k dk. Okay, so now I have exactly that form, except instead of p, so here I have with p equal 2/3, because it's p minus 1, and here I have 2/3 minus 1. So in other words, this is 1/3 times gamma function, because that's gamma p, right? Gamma p, so that's gamma function p is 2/3. And so the answer for this is finally the gamma function of 2/3 over 3, which I can, by the way, evaluate either using a computer system, or I could use the original definition to evaluate gamma 2/3, which I could go and integrate and get to the final result. But I leave the answer as such because the point is to show you how to express each of the following as a gamma function. And from there on, I think the remaining I've already elaborated on different questions, so I will stop here on this question. I think this answer should be sufficient. That concludes this problem.